The Dyson sphere, humanity's ultimate energy revolution, explores one of the most ambitious ideas in human history, building a colossal structure around the sun to capture its full energy output. This video dives deep into the science, challenges, and possibilities of creating such a megastructure. Could this be the key to infinite clean energy and the next step in humanity's cosmic evolution? Discover how this revolutionary concept could redefine civilization's future and transform us into a truly interstellar species. Our civilization is built on energy. From the first controlled fire that warmed our ancestors to the vast electrical grids that power our modern world, our progress has always been tied to our ability to harness power. But our current methods are reaching their limits. Fossil fuels are finite and environmentally damaging, while even our most advanced renewable sources capture only a minuscule fraction of the energy available to us. We live next to a star, the sun, a thermonuclear furnace of unimaginable power. Every second it radiates more energy than humanity has consumed in its entire history. Yet we capture less than 1/1,000,000,000 of 1% of this cosmic bounty. This is the core idea behind the Dyson sphere, a theoretical megastructure first popularized by the physicist and futurist Freeman Dyson in 1960. The logical next step, Dyson proposed, would be to build a system of structures to completely enclose their parent star, capturing its entire energy output. Such a feat would provide a virtually limitless and clean source of power, fundamentally reshaping what is possible for a species. When people hear Dyson sphere, they often imagine a solid, rigid shell completely encasing the sun, like a giant celestial eggshell. Any slight push or pull from another celestial body could cause the sphere to drift and collide with its star. Furthermore, the tensile strength required to build such a monolithic object is far beyond any material we can currently conceive of. Freeman Dyson himself never envisioned a solid shell. Instead, he proposed something more like a Dyson swarm. This concept involves a massive collection of independent orbiting habitats, solar collectors, and power stations flying in a dense, coordinated formation around the star. Each element would be a colossal engineering project in its own right, but together they would form a vast, decentralized cloud that collectively intercepts the vast majority of the star's light. The construction of a Dyson swarm would be the most monumental undertaking in human history, a project spanning centuries, if not millennia. The sheer amount of raw material required is staggering. To build a swarm with a radius of Earth's orbit, we would need to disassemble entire planets. Mercury, with its high concentration of metals and its proximity to the sun, is often cited as the prime candidate. We would need to develop automated, self-replicating mining and construction robots capable of stripping the planet down, processing its materials into usable components, and launching them into solar orbit to assemble the swarm. This fleet of machines would need to be a technological ecosystem, building not only the swarm's components but also more of themselves, creating an exponential construction process that could slowly but surely blanket the inner solar system. Once operational, the benefits of a Dyson swarm would be transformative. This is hundreds of trillions of times humanity's current energy consumption. With this power, concepts that are currently relegated to science fiction become plausible realities. Climate control on a planetary scale, terraforming barren worlds like Mars, and even moving planets to more favorable orbits would all be within our grasp. It would be the ultimate foundation for a truly post-scarcity civilization. This abundance of energy would also be the key to unlocking true interstellar travel. Powering massive laser arrays for light sail propulsion could accelerate spacecraft to significant fractions of the speed of light. reducing journeys to nearby stars from tens of thousands of years to mere decades. We could construct and fuel colossal generation ships, self-sustaining worlds in miniature, capable of carrying entire ecosystems and populations on multi-generational voyages to colonize other star systems. The Dyson swarm wouldn't just be a power station. It would be a shipyard, a launch pad, and a beacon, enabling humanity to finally break the chains of its solar cradle and spread its presence across the galaxy. This expansion is central to the Kardashev scale, a method of classifying civilizations based on their energy consumption. A civilization that can harness the full power of its home planet is a Type 1. One that can harness the full power of its star, a Dyson sphere civilization, is a Type 2. However, the path to becoming a Type 2 civilization is fraught with immense challenges that go far beyond engineering. The construction would require a level of global, multi-generational cooperation unprecedented in human history, demanding a unified purpose that transcends national borders, political ideologies, and short-term thinking. Such a structure could create a new stratified society, with a privileged few living in pristine orbital habitats, while others remain on a resource-depleted Earth. Furthermore, there is the existential risk. Concentrating our entire civilization around a single star, even within a structure as advanced as a Dyson swarm, could be a form of cosmic putting all our eggs in one basket. A solar flare of unprecedented magnitude, a flaw in the swarm's design, or a hostile action could lead to a catastrophic failure, potentially wiping out a significant portion of humanity. The very act of disassembling a planet like Mercury would have irreversible consequences for our solar system is gravitational dynamics, the long-term effects of which are difficult to predict. These are not just technical problems to be solved, but deep philosophical questions about the kind of future we want to build and the risks we are willing to take to achieve it. Despite these hurdles, the search for Dyson spheres has become a fascinating field within astronomy. The search for extraterrestrial intelligence, or SETI, has traditionally focused on listening for radio signals, but a Dyson sphere would have a distinct and detectable thermal signature. While it would block the visible light of its parent star, the structure itself would absorb the energy and have to radiate the waste heat away, most likely in the infrared spectrum. A star that appears unusually dim in visible light but glows brightly in infrared could be a candidate for a star enclosed by an alien megastructure. Objects like Tabby's star, which exhibited unusual and dramatic dips in brightness, have sparked intense debate and speculation, driving astronomers to consider the possibility that we might be seeing evidence of extraterrestrial engineering. While natural explanations remain more likely, each strange signal pushes us to refine our search and consider the cosmic fingerprints of advanced technology. The Dyson sphere, therefore, is more than just a futuristic energy project. It is a profound thought experiment about the ultimate destiny of a technological species. It forces us to confront the limits of our growth, the sustainability of our civilization, and our place in the universe. It represents a fork in the road for humanity's long-term future. One path leads to stagnation, resource wars, and eventual decline on a single, overburdened planet. The other path, ambitious and perilous, leads to the stars. It demands a future where we overcome our divisions, think on a time scale of millennia, and embrace our potential to become masters of our cosmic environment. The challenges are immense, perhaps insurmountable, but the vision it offers is one of boundless potential, and a future where humanity's energy needs are met not just for a generation, but for eons to come. Could this be the key to infinite clean energy and the next step in humanity's cosmic evolution? Discover how this revolutionary concept could redefine civilization's future and transform us into a truly interstellar species.